G'day lads, in this video I'll show you how to predict any UFC fight with a 72% accuracy by using Excel. If you want to have your own UFC picks backed by stats for every UFC event and want to learn more about sports modeling, then I highly recommend downloading this model by joining the Excel Lads Patreon. So before we start lads, make sure to click the first link in the description below. Your first step, lads, is getting data to analyze. So here I've got a data set from the website Kaggle. That link is in the description below for you to have a look at. And what I've got is 1,500 UFC fights. Both fighters in the match, that's the red fighter, who is the traditionally higher ranked or favorite heading into the fight, as well as their opponent, the blue fighter. Then I've got the winner for that match in column C. And from column D onwards, I've got stats for both fighters. So going across to the right, that's significant strikes landed per minute, significant striking accuracy, significant strikes absorbed per minute, strike defense, which is the percentage of opponent strikes that didn't land, average takedowns landed per 15 minutes, takedown accuracy, takedown defense, as well as the average submissions attempted per 15 minutes. So I've got from columns D to K, the stats for the red fighter, and from columns L to S, the stats for the blue fighter. These stats are available on the UFC stats website, something we'll look at later on in the video. That link is in the description as well. So this goes down to row 1504, where Volkanovski faced off against Kennedy. He got the win there. So that means there's 1,500 rows of data for us to analyze. Now in logistic regression, which is the process we're going to use in this video to find the win probability of the red fighter in our model, we only have a single binary dependent variable where the two values are either 0 or 1. In column C, right now, the winner for each match is text, either red or blue. We want to convert that to zeros and ones, where 1 represents the red fighter winning and 0 represents the blue fighter winning. So create a new column. In cell A4, type the text winner, and then in A5, I'm going to use an if function. Open bracket, my test is going to be if D5 equals speech mark, the text red, close speech mark, then return 1. If not, return 0. Close the bracket there. When I press enter, I'll double check. So Yanez won this fight against Lopez. He's the red fighter and he won, so he gets a value of 1. Copy that formula down by double clicking the bottom right of the cell, and then I can just do some further checks to make sure that when the winner of the fight is blue, 0 shows up and vice versa. So now select the whole column, right click, copy, and then I'm going to paste over the top, but I'm going to paste special. So go to paste special. I'm only going to paste the values. That way A5 down to A1504 doesn't show up as a formula, but rather just as a value of 1 or 0. Now that we've done that, we can remove column D because we've already got the winners as 1s and 0s. We don't need it as text. And our next step is to analyze how columns D through to S, the red and blue fighter stats, influence the values in column A, that is whether the red fighter wins or not. So to do that, we have to manipulate the data a bit. I'm going to go, after I make row 4 all bold, because we're going to make a few new headers in column T and across. So I'm going to go to cell T4, and here I'm putting the text SLPM difference. That is the difference in the red and blue fighters' significant strikes landed per minute. And the formula is quite simple. It's just going to be equals D5, the red fighter SLPM, or significant strikes landed per minute, minus L5, which is the blue fighter's value. Press enter on that. Right now, the red fighter has a 2.45 strikes per minute advantage over the blue fighter, and I'll copy that down to row 1504. Next, in U4, I'm going to put the text expected strike accuracy difference. And here I'm going to use a formula to come up with the difference between the accuracy of the red fighter and the blue fighter's strikes. So I'm going to go equals square root, open bracket. I'm going to take E5, which is the red fighter's striking accuracy, and multiply it by 1 minus the blue fighter's strike defense rate. So that's O5, double bracket there. I'm going to subtract another square root function. And this time I'm going to do the same thing but for the blue fighter. So M5, the blue fighter's strike accuracy, multiplied by 1 minus the defense rate of the red fighter. That's in G5. So close the brackets there, press enter, and I've got a value of 0.03, which again gives the advantage to the red fighter. Again, copy that down In column V, I'm going to put the SAPM difference. That's the significant strikes absorbed per minute difference. Here, you would want a negative value if you were the red fighter. So the formula is F5 minus N5, because this means that you absorbed less punches than your opposition. So that's a good thing. In column W, I'm going to put the text TD average difference. That's the average takedowns landed per 15-minute difference, and the formula is H5 minus P5 for that. The red takedown versus the blue takedown average. Now in column X, I'm going to come up with the title expected takedown accuracy difference, and I'm going to do sort of the same formula as I did in column U. It's going to be a square root function, open bracket, and I'm taking cell I5, the red fighter's takedown accuracy, and multiplying it by 1 minus the takedown defense rate, which is the percentage of opponent's takedown attempts that did not land, of the blue fighter in cell R5. Close the bracket twice, and we're subtracting the blue fighter's expected takedown accuracy, so Q5 multiplied by 1 minus, and then J5 representing the red takedown defense rate. Close the bracket twice and press enter. Then I can copy that formula down. And once you've done that, lads, we're going to do our last lot of data in column Y, and that's going to be the difference between the red and blue fighters' submission average, or the average submissions attempted per 15 minutes. And that formula is really easy as well. In cell Y5, you're just going to enter the formula equals K5, which is the red fighter's submission average, minus S5. Press enter on that, copy that down all the way to row 1504. And now, lads, we've got our 6 important stats that are able to measure the difference in ability between the red and blue fighter in our model. So what I'm going to do is select cells T4 through to Y1504, right click, and then I'm going to copy. Similar to what I did in column A a couple minutes ago, I'm going to right click again and then paste special over the top of cell T4. So paste special, and I'm only pasting the values. That way, when I check out the cells, they're just hard coded in there. So for example, just negative 0.5 and 3, so that any changes in the cells around it won't affect columns T through to Y. I'm then going to delete columns S through to D, because we don't need them anymore. What's relevant for our model is the difference between the two fighters, not the actual numbers themselves. So now we've got our complete data set with the two fighters in every match, the winner represented by either a 1 or a 0, and then the differences in columns D through to I. And lads, our next job is finding the correlation between these 6 stats and the winner in column A, so we can come up with a score for the red fighter in column B. And to do this, we can use a process called linear regression. That's up here in the data tab. Go all the way to the right there, click on the data analysis icon, make sure you enable that, and then select the regression analysis tool. The regression pop-up window will appear. The input Y range for that box, I'll select A5 to A1504. That's the dependent variable in the linear regression, what we're actually predicting, in this case the winner. And the X range is D5 to I1504. These are our predictors, what is predicting the winner. However, I'm going to change the rows in the range, because in our data set we have 1500 rows. I want to train the model on 75% of the data and then test it out on the remaining 25%. So I'm going to change this first range, the Y range, to A380 to A1504, and then the X range to D380 to I1504. That way, there's still 375 rows left of the data unseen by this model, which is rows A5 to A379, so we can test the model out. Select new worksheet ply, name it regression, press OK, and then a new worksheet named regression will appear with all our values and their coefficients. So the intercept is 0.53, and then we've got our 6 variables representing columns D through to I. We need to get the coefficients for these variables into our fight data worksheet now, so we can come up with an equation to get the red fighter's score. So go into fight data, and then I'm going to copy and paste cells D4 to I4 into B1. And then next to B1 in A1, I'm going to write the header intercept. So below it in row 2, we'll have room for all the 7 values come up with by the regression worksheet. We need to find a way to get them into the fight data worksheet. I'm going to use the transpose function for that, equals transpose in B2, regression B17 to B23. And so the scores come up like this, and then I'm going to copy and paste special over the top, only pasting the values. Great, now these values are hard-coded in, which means I can use them in the linear equation to produce the score for the red fighter going into the fight. So in J4, put the column header score, and then in J5 to work out the score for Yanez heading into his fight against Lopez according to the coefficients above, I'm going to go equals A2, absolute reference that by putting a $ in front of the column and row, and then I'm going to add the sum product function. Open bracket, my first array is D5 to I5. That's the difference in ability between the two fighters. My second array is the coefficients from the regression worksheet. That's B2 to G2. Make sure you absolute reference that array. Close the bracket, press enter. Yanez gets a score of 0.81 here. And then I'm going to double click the bottom right of this cell to copy that formula all the way down to the last row of 1504. Now I'm going to make a new column, K4, write the text win probability. So I'm going to use the score in J5 and come up with the win probability by going equals exp, that's the exponential function of J5, divided by 1 plus the exponential of J5. So close the denominator with 2 brackets, press enter, and then according to this initial formula, Yanez has a 69% chance of beating Lopez according to the coefficients from B2 to G2 as well as the intercept in A2. But this is a raw value. As the video progresses, we'll tweak the coefficients above in row 2 so that they become as accurate as possible. Now in cell L4, write the new column header likelihood, and in this column I'm going to run a test. If the red fighter wins, then I'm going to return his win probability in K5 using an if function. So if A5 equals 1, return K5. If the red fighter doesn't win, then return 1 minus K5. That is if the value in A5 is 0. So close the bracket there, and Yanez did win, so his likelihood stays the same as his win probability, but for rows 8 and 9, that win probability is subtracted from 1 because the red fighter lost. Now in cell M4, I'm going to make a new column and name it log likelihood. Here I'm going to return the logarithm of L5. Really easy, equals ln, open bracket, L5, close bracket, and then I'm going to copy this formula down to row 1504. And now lads, in cell J1, I'm going to write the text sum, and beside it in cell K1, I'm going to use the sum formula to come up with the sum of the log likelihoods from rows 380 to row 1504 in column M. So 380 to M1504, and then this is the data that the model was trained on. So when I press equals to that, I get a result of negative 756. Now I want to maximize this so that our model is as accurate as possible. So go into the solver icon within the data tab. I want to set the objective K1 to the maximum. So select the maximum button there by changing variable cells A2 to G2. These were the coefficients produced by the fight data worksheet, or the regression worksheet rather. And then I'm going to unselect the button make unconstrained variables non-negative, and then set the solving method to GRG nonlinear. When I press solve, it's going to change the coefficients in cells A2 to G2 so that the sum in cell K1 is maximized. So that makes the model as accurate as possible for us. I'm going to press OK, keep the solver results, and then we can do a quick double check that the coefficients have in fact changed, and you'll notice in column K the win probability has updated as a result of the coefficients and score changing so that it's much more accurate for us now. We can check this by going up to cell M1, typing in the text accuracy, and then in cell N1 recording the accuracy of the model. So if you remember in cells 380 to 1504, we trained the model on 75% of the data. Now it's time to test the model on the remaining 25%. That's rows 5 to 379. So I'm going to use the count if function. The range is L5 to 379, and our criteria is whether the rows of data are above 0.5. So if the likelihood is above 0.5, that means that the fighter that was predicted to win has in fact won. Then I'm going to divide this by the count of the rows L5 to 379 to get a percentage, and our accuracy is 0.7253 when reduced to a percentage. That's 72.53%. So that's that 72% figure that I talked about at the start of the video. And now we're going to create a new worksheet, name it Final. Here we're going to be able to put in the two fighters, their stats, and then come up with their projected win probability. So merge and center the cells B2 to C3. And then here I'm going to, after filling it with a red fill to represent the red fighter, the text red fighter. So as I said earlier, they're usually the higher ranked person in the fight or the expected favorite. So after merging and centering the cells D2 to F3, I'll put the fighter. I'm projecting the UFC 297 main event, Sean Strickland versus Dricus du Plessis. So copy and paste the red fighter and Sean Strickland into cell G2 and then change it to the blue fighter and the red fighter's opponent. Now I'm going to add a border around B4 to F16 and then do the same thing for G4 to K16. I've added images in there just of the two fighters. I skipped through it, but you can do that by going into the Insert tab. Now I'm going to merge and send the cells B17 to C17. Here I'm going to put the SLPM stat. That's significant strikes landed per minute. That's one of the 8 stats that we had at the start of the video. And I'll merge and send the cells D17 to F17 and then copy and paste that row 17 down 8 times to represent the 8 stats in the UFC stats website. So I'll remove the borders here, and then I'll also complete the 8 stats. So we've got striking accuracy, significant strikes absorbed per minute, strike defense, average takedowns, takedown accuracy, takedown defense, and then the last one in row 24, submission average submissions attempted per 15 minutes. I'm going to copy and paste B17 to F24 into cell G17 for Dricus du Plessis. So now we've got that template for both fighters. Then I'm going to merge and center cells B25 to F26. I'm going to fill it with, for the red fighter, red fill, and then for the blue fighter, blue. This is where we're going to put our win probability or win percentage for each fighter. That formula is going to be determined by the stats in row 17 through to row 24, which we'll have to enter ourselves. So add borders to this, and then I can also get rid of the grid lines by going into the View tab above and then unselecting grid lines here. So there should be a checkbox, and then it looks like this. Now lads, our next steps will be entering in the information for each fighter from row 17 down to row 24. So that's going to be in columns D, E, F for the red fighter and I, J, K for the blue fighter, in this case Strickland versus du Plessis. Now, right now I've pulled up the UFC stats website and I've got the stats for both Strickland and du Plessis. So that's in the box to the right under career statistics, all 8 stats for us to easily type in to rows 17 to 24. So I'll do that now. Strickland has strikes landed per minute of 5.82, a striking accuracy of 41%. He's got strikes absorbed per minute, a figure of 4.24, strike defense rate of 63%, and then takedown average 0.92, takedown accuracy of 64%, takedown defense rate of 84%, and then a submission average of only 0.2. So now I'll do the exact same thing for du Plessis. I'll bring his page up. It's very easy to find this website. Just search up UFC stats and then the fighter's name. And then all the 8 stats will be under, again, that career statistics header there. So strikes landed per minute, 6.95. Strike accuracy, 55%. 3.79 for strikes absorbed per minute. And already we can see du Plessis' stats are significantly better than Strickland. So in the end, when we do the calculations, the model should favor du Plessis. Right, so we've entered our fighters' information now. Those are the only stats we need. And through these stats, we can come up with the 6 stats we created in the fight data worksheet and then use the coefficients to make that linear equation. And so our formula for cell B25 is going to be fight data A2. That's the intercept. It's the intercept plus, and then all our coefficients multiplied by the inputs. And our first input is the significant strikes landed per minute difference between the two fighters. So we're adding to the intercept D17 minus I17 and then multiplying it by the SLPM difference coefficient in B2 of fight data. Now our next input is going to be the expected strike accuracy difference between the two fighters. So we're going to add the square root of D18 multiplied by 1 minus I20, which is Duplessis or the blue fighter's strike defense rate. So I20, and then I'm going to close the bracket twice before subtracting this by the blue fighter's stat, which is the square root of open bracket I18 Duplessis strike accuracy multiplied by 1 minus Strickland's strike defense rate in D20. So close the bracket 3 times there to close out the input, and then every time we put in an input into the linear equation, we multiply it by the coefficient for that input. So coefficient is C2 in fight data for the expected strike accuracy difference. Our next input is the SAPM difference. That's the significant strikes absorbed per minute. And to do that, we take away I19 from D19. So close the bracket there, and then we've got to multiply that by the coefficient 2 in D2 of fight data. All right, our next input is going to be the takedown average difference, and that's going to be Strickland's takedown average in D21 minus Duplessis' takedown average in I21. So I'll close the bracket there and then multiply it by the takedown average difference coefficient we worked out in cell E2 of fight data. Then I'm adding the expected takedown accuracy difference between the two fighters. That's going to be another square root function. So open bracket, square root, open bracket, it's D22 multiplied by, and then in brackets 1 minus I23, Duplessis' takedown defense rate. Close the bracket 2 times there, and then we're subtracting another square root function, open bracket, I22 this time multiplied by 1 minus D23, and then I'll close the brackets 3 times there and then multiply the expected takedown accuracy difference between the two fighters by its coefficient in cell F2. And then for the last one, that's just the submission average difference between Strickland and Duplessis. That's easy enough. It's just D24 minus I24. So close the bracket there and then multiply it by the last coefficient in fight data, cell G2. Click on that and press enter, and we don't get Strickland's win percentage just yet. If you remember, the process we used in fight data is we first found the score for the red fighter. In this case, Strickland gets a score of negative 0.63. We did that in column J. And then now using the exponential function, we can convert that to a win probability for that fighter. So I'll go back into final, and then I've got to wrap this score in an exponential function. That's an EXP function. So I'm going to copy this formula, producing the score for the red fighter, and then add the exponential function in front of that. Open bracket, and then close bracket after G2. And then I'm going to divide that by, in brackets, 1 plus another exponential function, open bracket, and then I'm pasting that score formula in. After G2, I'm closing it with 2 brackets. And when I press enter, I get Strickland's decimal chance of winning, which I can convert to a percentage. And we can see the model says he has a 34.6% chance of beating Duplessis. And to find the blue fighter's win probability, it's really easy. It's just 1 take away the red fighter's chance of winning in B25. So I press enter on that, and we can see Duplessis is considered the favorite by the model with a 65% chance of winning. And I'll make this percentage to 2 decimal places like I did for the red fighter. and to be exact, it's 65.4%. Now, the win probability for each fighter changes when the differences in their ability changes. So for example, if I increase the strikes landed per minute by Sean Strickland, say to a value of 7, then his win probability should increase because he's considered a stronger fighter as a result if he lands more punches. In the same way, if I increase his striking accuracy to 60%, suddenly he becomes a favorite over Duplessis, and I can do the same thing for many of the other stats. If I say increase the strike defense rate, then the win probability for Strickland should increase, but say if I decrease it, which is bad, then it would decrease. And to prove my point there, if I go down to cell D23 for the takedown defense for Sean Strickland, if I decrease that to a value of 50%, that means he's less able to repel Duplessis' takedowns, meaning he's a weaker fighter, and as a result, that win probability has dropped from 57 to 54%. Something you can also do, lads, is delete rows 4 to 16. That removes the profile picture of both fighters, leaving just the red and blue fighter names, their stats, and the win probabilities in rows 12 to 13. But I'll leave it as is. So thanks for watching the video, lads. That's it. Make sure you click the first link in the description below to download the model and improve your sports modeling skills.